graphing in standard form. If I forget, try to remind me. We'll talk at the end why this is called standard form. But what was the form that we looked at yesterday? What was that called? Okay. We had a shortcut for graphing. Had the slope-intercept form. Right? And I like slope-intercept form. Slope-intercept form, just to review, is y equals mx plus b. That's slope-intercept form. And what identifies it is that we have y equals. Okay? That's kind of how we know something is in slope-intercept form, is because it says y equals. And then m was the slope, and b is the... Okay, intercept is... Yeah, the y-intercept. And it's only part of the y-intercept. It's the y part of the y-intercept. What's the x part of the y-intercept? 0, right? The x part of the y-intercept is always 0. Okay. And you saw that it's pretty easy to graph things in this form, right? With that shortcut. We just like plot the intercept and then we use the slope. Now standard form is maybe a little trickier. I'm going to show you some tricks. So standard form is, make sure you write this down. Actually, I'm not going to use capital letters. So this should be in your notes for today. AX plus BY equals C. Okay. And I want to say something. A lot of times you'll see this with capital letters because this B is not the same B that's in slope-intercept form. Okay. This is just 3 different things. AX plus BY equals C. So you can see this example here. A is 2, B is 3, and C is 12. So how would we graph something in this form? Yeah.
So would it be like, so would it be like the 2x, is that showing us that it's on like the 2? And then like the y is where it's on.
How can we know?
This point is on the y.
How would we know?
Well, just because like it's
What?
the formula.
Okay.
It says like AX.
I'll give you a hint. We can always graph anything by using a t-chart, right? So if you think that x would be 2, you can just say, okay, if x is 2, plug that in and find y, right? Does that make sense? So if x were 2, we would have 2 times 2 plus 3y equals 12. So we'd have, move this over here, 4 plus 3y equals 12. Subtract 4 from both sides. 3y equals 8. Y equals 8 thirds. I mean, that's a point on our graph. It's not a particularly useful point. But it totally, I mean, we could plot it if we wanted to. Let's try to, there are easier points to find. So I want to try to figure out what those are going to be. I'm going to use a different color. What did we start with the first time you ever learned how to graph? What do we start with for x?
0.
0. Wouldn't 0 be kind of nice here too?
Yeah.
Yeah, so let's do it. If x is 0, whoa, that just made this so much simpler. 2 times 0 is 0, right? So y is just 3y equals 12. Divide both sides by 3. So y would be 4. When x is 0, y is 4. What point is that? Okay, but what is the name of that particular point?
It's the y.
It is. That's the y-intercept, right? So our first point, 1, 2, 3. Oops, I'm going the wrong way. 1, 2, 3, 4. Our first point is at 0, 4. That was really easy. But we can't make a line with 1 point.
1.
We could do 1. Yeah?
Can we do a common multiple of 2 minus
we could try a common multiple of 2 and 3. There's something that's even easier. We've always picked x's and found y, right? Do you have to do that? Yeah, couldn't we pick a y and find x?
Oh, yeah. So we put y is 0.
Yeah. Let's just do like the same thing again.
Oh.
If y is 0, boom, 2x equals 12. We divide both sides by 2, and x would equal 6. So when y is 0, x is 6. What point is that? You actually haven't learned the name, but yeah, it's the x-intercept. 1, 2, 3, 4, 5, 6. Put a point there. And then, oh, look, perfectly straight line. Wow. That's a little bending, but just pretend you can't see it. All right. So we're typically going to graph in standard form by just finding 2 points. We'll find the x-intercept and the y-intercept. These ones were nice, and the ones on your homework are going to be nice. Just double check. Yeah, they're all nice. Okay, let's do one more example. Just like that. So what if we had 5x minus 3y equals 15. Here's my graph. I like to make a t-chart for these. It's pretty easy to do, right? And it just helps us remember, okay, when x is 0 and when y is 0. So when x is 0, what would y be? We'd have negative 3y equals 15. Divide both sides by negative 3y is negative 5. So 0, negative 5. 1, 2, 3, 4, 5. That's right there. Okay, when x is 0, we just did that. When y is 0, 5x equals 15. So y would be 3. Wait, I did that wrong, didn't I? What was wrong about what I just did? What point is this? What negative? 0, negative 5, right? Oh, I did it right. What am I talking about?
Yeah.
Okay. What am I thinking? Okay, and now I'm doing the other one, right? 3, 0. Okay. I don't know what I was thinking.
How do you check your answer?
Yeah, there's not really a great way of checking your answer. The way that I would check my answer on this is I would do it again, and I would just see. Yeah. I will show you, because I have to, that there is another way of graphing these. You can always plug in other points. You could say, what you want to try to do is find something that would work well. And that's pretty hard to do. But I could just plug in x is 1. Right? If x is 1, then 5 minus 3y would equal 15. So negative 3y would equal 10. So y would be negative 10/3, which is somewhere around here. So that looks pretty close. It's a little off my line, but it's pretty close. So I could kind of check my work by doing that if I wanted to. But it's hard to find points that are going to line up right on the line. Okay. And let's do one with some more negatives. Because that's sometimes a little confusing with these, is what if we have a whole bunch of negatives? So what if we had something like this? Negative x plus 2y equals 6. Negative 6, because I said a whole bunch of negatives. Okay, so we've got a couple of negatives in here, right? Doesn't change our process, but it does affect the results. So, x is 0, y is 0. So if x is 0, 2y equals negative 6,
Negative 3.
negative 3. If y is 0, negative x equals negative 6. Divide by negative 1.
And then it's just 6.
Yeah. X equals 6, right? Okay. Let's graph that. 0, negative 3, and 1, 2, 3, 4, 5, 6, 0. Does that make sense? Okay. We have to look at kind of well, we're going to look at 3 special cases, but one of them looks very similar to this. So here's our first special case. What if I have something like this? 3x plus 2y equals 0. So go ahead and start to graph this and tell me when you've encountered a problem.
Yeah.
0 divided by 2 is what?
0.
0. It can, right?
So it would just be 0, 0. And then
Okay.
they again twice.
Yeah.
Yeah,
So like a
both
dot on the
points
board.
are 0, 0. Can I make a graph
Not really.
from that?
It's
It's
just,
not-
well,
it's
it's
not
not a
linear.
line, but it's just a dot.
Right. So I can't, I've only found one point. I found the same point twice. You see what happened? It's like when I plugged in 0 for x, y was 0. Oh, well then when I plug in 0 for y, I better get 0 for x
So it's like impossible.
on a line.
Yeah.
There are other points though, right? I mean, if I plugged in 1 for x, I could solve that. 3 plus 2y equals 0. I could totally solve that. So there's a couple strategies you can use to graph when standard form equals 0. I think the one that I like best, I don't totally know actually, but I think the one that is easiest is to just turn this into slope-intercept form. So remember, slope-intercept form says y equals. So I'm going to get y alone on one side, minus 3x, and then I have 2y equals negative 3x, and then I just divide by 2. So y equals negative 3 halves x. And I'm going to write it like this, with the fraction in front. Remember, when you multiply something times a fraction, it multiplies times the top. So negative 3x over 2 is the same thing as negative 3 halves x. Right? And then I can just use the slope to get my next point. I can just go, okay, down 1, 2, 3, over 1, 2. Down 1, 2, 3, over 1, 2. Right? That line is like nowhere near straight, but it's a sketch. I'm sketching the graph. So this is one way of doing it. We subtract the x's over, divide by the coefficient on y, and then we have slope-intercept form. We only have to do this if what? Yeah, if it equals 0, right? Otherwise we can just find the intercepts. Now, we could also, like I was saying before, you could just pick something for x and find what y is. That's the other way of doing it. Like I could say, okay, if x is 2, I'm going to find out what y is. And it would be negative 3 in this case. But the one thing that I like to say about graphing over and over and over and over and over, you can always graph something using a t-chart, right? We're going to show you kind of all these shortcuts, like you learn the slope-intercept shortcut. You're learning now this kind of x and y intercept shortcut. You can always make a t-chart, pick a point, plug it in, and solve for the other variable. Right? You can always graph that way. So here's our other two special cases. X equals 5.
Yeah.
Which one is the x-axis? This one, right?
Straight across.
Here's my x-axis. Here's my y-axis. So where would x be 5?
Just be 5 on the, like 5 across.
Yeah, 1, 2, 3, 4, 5. So we can all probably agree that that has to be a point on our graph, right?
Yeah.
That's where x is 5. Is that the only place that x is 5?
No.
Where else is x 5? On the other side, x would be what though? Negative 5. Okay. On the y-axis, is x 5 up here?
No.
What is x right here? At this point, what is x? X is 0, right?
Oh, actually,
Yeah. Go ahead.
you just go up because x is always 5. If you're going straight.
So are you saying that right here, x equals 5?
Yeah.
What's this point?
It's 5 1.
5 comma 1. Oh. Wait, what about up here?
Yeah.
What point is that? 5, 5.
So it's kind of like
So it just goes, well, this is kind of a weird graph. It just goes up in like one direction?
Like the y1 and 2 is just going to go like -3. And then just all the way across to -3. Oh, yeah.
Oh. Wait. What is this point right here?
That's 5 -1. Oh.
Is x 5 then?
Yeah.
Oh. Can I just keep going down?
Yeah.
Right? X is always 5 right here. Now this is really confusing when you start to think about it. Because the x-axis goes this way. But when we graph x equals something, that's a vertical line.
What? Because x
Right?
always-
Because this is where x equals 5.
And for y, that
And for y, it's like the
Okay, so now let's think about y equals -3. Where do you think this would be on the graph?
down 3 on the y.
Down 3 on the y, and then what?
Just straight, like
Just
parallel to
straight
the x-axis.
parallel to the x-axis. Yeah. Because y is, if you think about, remember we can always make a t-chart. If you think about this one, I could pick any number for x, 323. I mean for y. What is x? X equals 5. Right? There's no place to plug y in, so x is always 5. Doesn't I could pick like -√7, and x would be
5.
5.
And then it's just always on that line.
Yeah, it's just always there. It doesn't matter what y is. X is 5. X is always 5.
So kind of like on like if you're using like
Y
graph
is
paper,
always
if
-3.
you're using graph paper, like all the lines that are going like up and down are the x lines kind of, and all the lines are going like this way, like the y lines, even though like x and y is opposite x.
That's kind of a weird way of thinking about it, yeah. Yeah. Cool. So, this gets back to the thing we started with, standard form. Remember we said standard form is ax plus what? Uh-huh. Okay. Is this in standard form? What's A?
0, 1.
A is 1, right? 1x. What's B? 0.
Y is also
Y. And what's C?
5.
So,
So 1x plus 0y equals 5. X equals 5.
And it looks the same way.
So wait, I have a question though. Could you write this in slope-intercept form?
well, didn't you
Well,
just write it?
This is standard form.
It'd be
I have 1 under x.
No,
Could you write this in
Yeah.
slope-intercept form?
It would be 1 over 1x. No, because it doesn't move.
Because it doesn't.
There's no y.
So
There's
it's
no
just-
y.
Yeah.
So slope-intercept form is y equals, right?
Yeah.
Can I find y equals here? No. So that's why, that's the whole reason that this is called standard form. You can write any line in standard form. You cannot write vertical lines in slope-intercept form. Why? What is the slope of this line?
Nothing.
Well, let's think about it. Here's a point and here's a point. So I go up 1 over how many?
0.
What?
So it's just,
It's just 1.
1 over 0?
That's just
that
1.
doesn't make sense because that's,
It's just 1.
no, because 1 divided
1
by
over
0
0?
is 0.
1 divided by 0?
Oh, no, that's 0. If it was
So it just doesn't work.
Yeah, this, do you guys know if you divide by 0, like anything divided by 0, there's a term for it. It starts with undefined. So our slope is undefined. We can't divide by 0. So the slope here is undefined. We can't write this in slope-intercept form. Let's look at this one now, though. So y equals -3. Is that in standard form? Is that in standard form?
Yeah.
Yeah, what's x? What's a, sorry.
0.
What's b?
1.
What's c?
3.
-3. Okay, is this in slope-intercept form?
No. Wait, yeah. Yes. Y equals something.
Well, yeah.
Y equals.
Yeah, it's because if it's on the y-axis, then it can be
What's our slope?
3.
What's the slope here?
3 down.
So let's think about it. If we were to write it in slope-intercept form, we would write y equals something x minus 3. What's in front of x? 0. So what is our slope? 0. The slope of this line is 0. Think about what we do to get from one point to the other. We go over 1, but how many did we go up? 0 over 1 equals 0 divided by 1 is 0. You can divide 0 by other numbers. 0 divided by 7 is 0, right?
Yeah.
If I have 0 pies and I split them among my 7 friends, each friend gets
0.
exactly 0 pies, right? But if I have 7 pies and I split them among 0 people,
You get 7.
that doesn't make any sense.
You get 75.
Unless they're your imaginary.
No, because no one is there to get the 7 pies. So you can't divide 7 pies among 0 people. Right? I can't put 7 things in 0 piles, right? That's another way of saying division. It doesn't make any sense. But I can put 0 things. I can say like, okay, here's your pile and here's your pile. There's nothing in it. But I can make as many piles as I want, right? All right.